Hello, good morning. Thanks so much for joining me in my shop for another step forward with this radio. Now you can see I've got a couple of capacitors I found here that I wanted to replace these two with. In the last 20 minutes, just before I started this video, I've been studying the schematic, and in the schematic it shows one capacitor, not two, inside. See, it is inside this metal box here. So because I can't quite sort out what the second capacitor is doing, the wires are all buried under here, I can't sort it out, so I'm going to skip that for now. And we're going to carry on with the new solid state. I guess we still have to call these a vibrator, even though there's nothing vibrating in them anymore. So here we are. So I'm going to pop this guy in here. We're going to try running this radio just off the 6-volt power supply. We'll worry about those capacitors later. Okay, now we need a rectifier tube in there. Pop this in. There we go. So now the radio is just the way it would be if it were in a car, ready to operate. Great. Let's see now. Just making sure I haven't forgotten anything before I power it up. Switch is off, speakers in. We're on selection number 4. Okay, power supply on. Okay, I'm just anxious as always just before doing this. Okay, let's hear what happens here. Oh, wait a minute, we're not going to get anywhere here. This fuse holder, oh, for crying out loud, isn't much of a holder. Doesn't seem to hold the fuse. Okay, let's just power off here while this keeps just popping out. Yeah, these, when you put them in and turn them, they should lock, so they can't turn back without you pushing them a little bit. But this one's got no locking to it at all. It's going to back itself out every time. Okay, future problem, little problem. Power back on. 6 volts. Yep. And for an antenna today we have nothing at all. Let's get something on there down amongst all this stuff on my bench here. Okay, I got a little piece of wire for an antenna, a really crummy antenna. Here we go. Current draw going up. So we're drawing about almost 5 amps. There it is. Not tuning anything. Well, that's okay. It's working. That's the primary thing. Now, it's making a rather scary kind of noise there. Let's see if we can get away from that. Let's try this. Here we go. So just a little bit of help with my finger. Got it to go. Let's go another one. There we are. So again, maybe I just don't quite have enough power coming to this. Let's pull this out. And we're tuning. 640 here. Nothing. So there's still more to do with the alignment. So I think that's what's going to... So what I'm listening for now is noises or sounds coming from the vibrator power supply. I don't hear anything. It's a very... Oh. Let me play this right up near the microphone here so you can hear this sound that's coming out of the speaker. You should be able to hear it there. So that's an underlying tone. Well, I'm going to guess that's actually the sound of the it's caused by the solid state vibrator. Don't know though. But where else could a sound like that come from? Great. Okay, so now we're going to move on to do the alignment and do the last stages of the alignment on the radio. And we're almost done here, really. Let's put this up this way. It's over. So, the instructions are all about turning these guys here, these two guys, and there's three things to adjust. Those two, one is the local oscillator, one is the RF front end tuning, and then the last one is a coil, a slugger coil somewhere in here. I'm not exactly sure where, so we'd like to locate that. L6 oscillator shunt coil. L6 appears to be, wow. Let's take a look at this on the screen here. Okay, so we're looking right in this area here. Oop. Oscillator shunt coil. L6 adjust core through hole inside. Okay, glad I saw that. Okay, let's take a look at the hole in the side. The hole in the side. And of course the side is down here. I've got the radio on the side. Phooey. So can't do it like that. So lay it right on it, right upside down. It's a little tricky too. Okay, perfect. Now we can get at the two trimmer capacitors and the hole. This is the hole right here. Oh, up into this coil here. Yes, of course. Okay. And you know what? It's tuned by. It's something. You know what? It's the one kind of tuning thing I don't have a tool for. That's okay, I can do something with that. So we're all set actually. We're all set and ready to go. Just peek at the instructions here very quickly. Set signal generator 265, we did all that. Oscillator alignment. Connect signal generator leads through dummy antenna to dummy antenna lead in socket on receiver. Through dummy antenna lead in socket on receiver. Okay, so the antenna lead coming out of here. That's just, hey man, your shop's a bit of a mess here. I'm usually in here in the evening doing my own projects, not necessarily shop-oriented stuff, but sometimes I'm in here in the evening making a mess. Okay, now we're a little better off. So we want the signal generator to be producing, I think it was 535. Okay, 535. The radio tuned to 535. Oops, didn't want to do that. Just kind of roughly have to kind of estimate 535 there. Signal generator output. Through a dummy antenna. Make that out to be a small capacitor. Not a particularly small capacitor. Okay, signal level's low to start off with. Are we ready? I think we're ready. Okay, switch on. Volume up. Okay, let's get it tuned in here. Oops. So the radio's displaying a lot of sensitivity already. So I don't know what those sudden flicks are of the meter. I did a pretty thorough job cleaning this guy up before I put him back in service here. Obviously it didn't work. That's a little better. Jeepers creepers. Okay, good enough. Now, what we want to do is adjust first a local oscillator. Well, let's see. We see 535. So what's being transmitted? What are we receiving here? So that looks like about 575. Okay, so let's find out now which one is the adjust local oscillator C9, C9, C9 in the middle, C9 right here. Adjust that baby, see if we can. There. More or less focused, I think. Autofocus. Yeah. Oh, the capacitor's moving. Adjusting screw is really stuck. Oh my gosh. There it goes. And the radio didn't change. Oh my gosh. I need a larger screwdriver I can torque this with properly. Not that big. I should have knocked the should have affected the local oscillator. I should have knocked the tuning out on the radio on this. There it goes. Okay, now we're in business. Okay, so how many times can you say okay in short order? We're gonna go up. Now, so this is set to 535. I'm gonna move the tuning where I want it to go. Right there. Tune it back in with this. Good, the rate passed. And now go here, tune the right thing. Okay, so the dial on the radio is now set to 535. But I think it's 535. Okay, that's it for that. Now the next one is actually more important. This one just corrects the dial accuracy. The next adjustment should make the radio more sensitive yet. Okay, so now we set it to signal generator 1200. Tune to 1200. Adjust converter trimmer C7 and antenna trimmer C2. There's too many C's in there. So C7's here. Where's C2? I'll have to hunt down C2 here. C2. C must be up here. Print is so small. Okay, won't worry about it right at the moment. Let's get 1200. 1200. Okay, so we're set to 1200. We'll tune to 1200 on the radio now. Well, I didn't hear it. It's extremely low signal. Let's put it up this high. I'm bound to hear it now. A huge amount of play in the tuning control. Probably true of the steering wheel on this car too. So now we're adjusting C7 for maximum response. C7's right here. Okay, watching the meter. That's a hair trigger. That was pretty much right on. And the last one is the C2, which I have to find. C2. Where are you, C2? Let's take a look at the schematic here and see if we can find it. Okay, turn down the radio a little bit. So let's look somewhere else here. Here. Adjust. So we did this C9, and then 1200, C7, and C2. So C7, the one I just did, right there. Now, where would C2 be? Doesn't appear here, so let's look up here. Foot switch, speaker socket, tone control, on-off switch, pilot, station, antenna trimmer C2. Oh, this is the one that's underneath the knob. Right. So this one really needs to be done in the vehicle, but we're going to do it here too. Okay, C2 under the knob. C2 under the knob. This knob. That play might be because I have it on here. Yeah, I do. I have it on here loose. That's what the play is. I didn't have the screw tight. See, there it is. Down on an angle like this. Can you kind of see it down in there? That's a little tough on the camera here. That's okay. So once again, we are now going to adjust this with my small screwdriver for maximum on the meter. And make sure we got it tuned in properly here first. A little bit of trouble because there's so much noise around it. Let's give it a little more signal here. This will settle the score. So what's happening, see, the output has pretty much stayed the same here, oddly enough, even though I cranked up the output of the signal going in here and all cleaned up sound wise. Automatic volume control. That's what's doing it. So I think we're okay here. Let's try tuning again. We're doing something a little bit funny there. I think that is tuned dead on to the signal. Okay, screwdriver's in. I'm watching the meter now. Screwdriver fell out. Wow, this doesn't do anything much. There's a little wee bit happening there. this will have to be done in the car. This is where this really needs to be done. Sure, it doesn't seem to make any difference. Now again, I've got the signal up so high, I'm probably wrecking the test. Let's try it with less signal. It doesn't seem to be terribly sensitive to anything. So this adjustment, as I said, has to be done in the car. Let's tune to the other end. How about that? Okay, so we're tuned to, let's say, 6. We'll set this to 600. Oh, what to go here? 600. Okay, that's maximum there. Got the signal back. This radio is really sensitive on the lower frequencies. And we'll try adjusting it here. That is a bit of a peak. Now that's based on my antenna arrangement here in the shop, which is invalid compared to what's going on in the car. So the owner of the radio, once he installs it back in his car, he has to do this procedure, or should do this, to try to get the most out of it. But that seems to be about it. What about that L? I skipped over the L. The L. What was the L? The L is part of the oscillator. Oscillator shunt coil. Maybe we'll just leave that alone. I think the radio is working fairly fine. It's an oscillator thing again. It doesn't involve the signal strength of the radio. It just involves where on the dial the pointer is when you're tuning stuff in. So let's put some kind of antenna on here and see if we can pick up anything. So I have the feeling I've reached the end of the road with this radio right now. So all I'm putting on is about 5-6 feet of wire here. Okay, so it's working great. This is pretty good response down here with a piece of wire and what's going on around here in my shop. But I'm going to get a powerful loop antenna, bring it in, we're going to hook it up to the radio and see what it does with a really good signal. Okay, here's a look at the antenna I'm about to hook up. Okay, it's this great big thing here. Yeah, no, you're not going to have this on the top of your car when you're driving around. But we're going to try this in the shop here. So we'll just hook this up to the antenna. Where's the antenna? Here's the antenna. Now that big antenna, it needs to be tuned just as much as the radio itself.
In 1998 to 2000 in Calgary, when he came in as a, nobody because he wasn't drafted, and you could really see the upside to him, and he didn't even know saw the upside to someone who was 5'8", being that they had such success with Theron Fleury, but he just went on to just be amazing. He had Art Ross twice, Ted Lindsay once, Lady Bing 3 times. Just an amazing kid. Do you think he has a shot on his first vote?
I definitely do, Sherry. And you know, you mentioned about his size. Imagine if he was playing, you know, and I know he just retired a couple of years ago, but the game has changed so much in the last 3 or 4 years. It's a game where the Johnny Gaudreaus and the Mitch Marners, teams are actually looking for players like that, even though they're so slick, they're diminutive, because of their speed and their skill. And you just wonder.
So what I got out of that little experiment there of first tuning the loop antenna and then turning its angle around is that the I forgot the word. How can I forget the word? The receptive strength, the sensitivity of this radio is really, really high, and the automatic volume control is very effective. So even with a weak signal, it's producing pretty darn good sound. So even as I move the signal strength up and down by tuning the antenna or rotating it, you didn't hear a lot of change in the car, which is really quite impressive in the car radio, which is really quite impressive. But there was a point where I had the antenna turned in its weakest position, and I could hear the radio weaken. So no question, that was all. It's really good. It's a really good.
If you look at McGillney's
Good radio.
numbers,
Let's
they are
tune around a little
very
more.
equitable to Pavel Bure's, if not exceeding.
So that's
those
probably
other two
640.
guys in the hall without. In the league is
0% APR purchase financing.
This is probably 680.
Brand new 2018 F-150 models. Visit FindYourFord.com. For used in Toronto, this is 680 News.
680. There's 680. 680.
Partners like
640. 590. So we're a little off on the dial. So regardless of what I did, it didn't work. So we're going to move the dial a little further yet.
To diminish the guys in this class, because they're all, you know, I mean, well, Marty Brodeur, I mean, I could even think that's such an easy pick. I mean, the guy that has the most wins and most shutouts in NHL history. But, you know, this isn't a class where there's 3 or 4 slam dunks like we've seen it in the past. So maybe the door is open
590.
for this year.
Links with them or other things to say, you know what, until women
640.
can drive, until they have basic rights there, I really...
Dwayne Casey won the Coach of the Year award.
680, right where they should be.
Complete round robin that the world does today. Sports Report.
I'm going to tune the antenna now. Something a little odd happened there. I don't know if you picked up on that. I was tuning the capacitor on the antenna and nothing was happening here. Then there was a small click. The radio got slightly louder, and then from then on the capacitor was having an effect. So maybe there's a loose wire on my antenna or something. Doesn't really matter. The fact is the radio's working great. And what about, you know, maybe when I push these buttons, it's not working 100%, it says, without trying, because the radio's upside down. Just maybe. Lots of heat in this. I find I can feel heat with the back of my hand better than So it might just be heat from the tubes coming up. Oh, I will be copyrighted out of the ballpark here. So if the video is a little choppy at this point, it's because I'm trying to overcome a copyright hits because of the music playing out of here, which I forgot about. One. I noticed before it seems to like 2 pushes to make it operate. 3. Okay. So out. Adjust.
Numerous charges of complaint. We'll see if any of those allegations are able to result in convictions. The police certainly seem to think
680, I think.
might
Good.
happening in Ottawa around the same time that we've been having this conversation.
Okay, so what's left in this radio now are 3 fairly large paper capacitors, 2 of which I'm a little bit concerned about, which I have the replacements for here, which I've left in at this point, and I'm also, ooh, that guy's hot. But, a little surprised at that. Quite a bit of heat in this new solid state vibrator. But I think we're done. Some of that heat could be from the rectifier tube right beside it. So the transformer's a little worn too. Oh my gosh. Okay, there's something that's not right here. Okay, a little more going on here, folks. We're not done yet. This is the filter capacitor, and it is really hot. Really hot. Let's see. Let's check all this stuff out here. So first of all, bench temperature at the top of my bench, 22 degrees. Temperature on the ceiling, 22.1 on the floor, 18.5. Okay. Temperature of the transformer here, 33. Temperature of the vibrator, 22. Now this is a shiny metal surface, so you really can't rely on these guys. The emissivity of a shiny surface is way off from other surfaces. To my hand, this is hotter than this. 33, 22. It just shows you've got to be smart about using these kinds of instruments. Now this thing, it also is a shiny surface, so I don't think the reading's going to be valid. 26. There's no way that's 26. So the surprising thing is this is a capacitor, and frankly I've never come across one getting hot like that. So is it being heated by adjacent things like this tube? This tube is quite hot. This is a totally invalid reading of 63. Okay, so that's a totally invalid. 63 means if I touch it, it hurts. It's not that hot. This is not 63. Okay, so this is hotter than the top of this tube. There is something going on, and this is a capacitor. It should not be getting hot. It's really getting very hot. Okay, so I think this has got to be considered a problem. So now we've got basically all the large filtering capacitors in here to be concerned about. And 2 molded capacitors, one here, What did I just feel there? I felt my imagination. That's what I felt. Yeah, let's not let things get any hotter than they already are. So that's what's got to happen on this radio before we're done. Just the last thing, we'll take a peek on the schematic, and I'll leave that in my head. Wow, I'm glad I noticed that, because you know, I've never found one like this. Getting hot like that. It'd be interesting to test it once it's. Well, I'm not likely to remove this from the radio. I'm likely to remove it electrically, but leave it here physically. There's not much advantage to removing it completely. Let's look at the schematic here. So the filter capacitor, the metal can one, is right here. It's a 20 and a 10, right on the B plus high voltage. It's quite important, you know. We did hear a bit of a buzzy sound too coming out of the speaker. It could be these filter capacitors are not working well enough. That's possible. So there's those two, and then here, this is where I said I can see 3 capacitors, but there's only 2 on the schematic. So the 3 I can see, one is this one, 0.5, one is this one, 0.5, and the last one is anybody's guess as to where it is in here. I can't find it. It is inside this metal can. Maybe it's on the top side. Maybe it's okay, so I'm looking at the top side. Well, you know what? It could be that last molded capacitor. That would not qualify as being in the can, though. So I don't know. It's not working out. There appears to be another capacitor in here somewhere. Certainly not this one. This is a small one that's been replaced already by the previous guy. So that's what we're after. When I first put the DC power using my shop supply on this, I found there was a little bit higher current flow than I'm used to seeing. But I don't think that can be because of this. You know what? It can be because of this. Because this would have been energized. Wow, that is really hot. This would have been energized from the shop supply. So that's probably the current draw that I could see. This can't get hot without, you know, some I squared R happening in it. I don't want any R in there. No R. Okay, so that's it for today. Thanks so much for watching. And tomorrow I'll do the capacitors and recheck the radio, and I think we're done with this one. But remember, I got another one exactly like it. Okay, see ya.